Our next speaker is Ryan Nolette. He's previously spoken at other SANS events before. And if you guys are familiar with the company Squirrel that Amazon had acquired a few years ago, right? Ryan was at Squirrel and was at AWS. He's currently the security lead at Postman. But before joining Postman, he worked on one of the relatively newer AWS services, AWS Detective. And so today, Ryan is going to be talking all about, well, hey, leveraging some free tools for security testing. So Ryan, I'm going to hand it over to you.
Thank you very much. It's an absolute pleasure to be here. So as a quick highlight, this was written and submitted when I was working at Postman. I am no longer there. But just remember, as in most of my talks, my opinions are my own and don't reflect my employer's. So let's kind of dig in and talk about some of these topics, right? So with the increased usage of cloud infrastructure services, there's a growing need for automated systems to provide notifications on access control violations and different use cases where we need to pull this kind of information periodically. And we really want to use automation to offload a lot of that heavy lifting. What we're going to do is we're going to go over some collections and some scripts and tooling in order to automate a lot of this and iterate over your different environments and databases and report those violations. In the demonstration, I'll guide you through a few different access auditing use cases in AWS specifically, and a private attack collection that I created in order to test the auditing by exploiting access controls and actually getting data exfiltration. So we would really want to emphasize not just why we need to monitor the access, but also what happens if we don't. Here we go. So once again, welcome. Thanks for coming. What we're going to really talk about is leveraging REST APIs, right, for security testing. So we're going to cover two examples, one being defensive and one being offensive. And we'll get into why the REST API is really important here. So as I said, I'm Ryan Nolette. I'm currently a security engineer for a different firm. I'm no longer at Postman, but as was mentioned, I'm the co-author of AWS Detective, and I also had input on a lot of the other AWS security services and their finding formats and things like that while I was at AWS Security. I'm also the co-author of Huntpedia, which is a threat hunting guide that was put out with Squirrel with a bunch of other absolutely wonderful threat hunters that I'm happy to be in the book with. It's wonderful. All this code is going to be up on my GitHub page. So if you guys want to pull anything down, you can grab it. Sharing is caring. It's up there for people to use. All right, so let's kick in. What's the problem we're trying to solve? And that starts off with, well, a lot, right? There's a lot of these problems that we have. AWS auditing for IAM is not always the most straightforward because people have inherit policies, they attach things to groups, they attach them directly to users. Some are using single sign-on, so they have additional permissions added that are being brought down from an identity server. You can hear this list ticking on and on and on. But the biggest issue I think we need to solve in the short term is how to have repeatable, consistent notification of basic compliance. And that compliance standard is definitely going to be different for a lot of companies. Previously, I was in some startups that were a bit looser. Now I'm more in the financial sector where there's a lot more regulation required, as well as a different risk and attack surface. So all of those get kind of tweaked down to the bare essentials, and we're going to talk about what's called the AWS Best Practices. We know that this has been mentioned a few times previously in different contexts, but in this case, how we're representing it is that the AWS Best Practices is a fork of the CIS AWS security controls, right? That's reviewed by a bunch of systems and security engineers over at AWS, and they basically tune it down to what's more service specific. So it's just kind of a little bit of an offset. And with these best practices, what we're going to do is kind of work our way backwards. First, we have to define what we're auditing for and what is not an acceptable answer. For this, I'm leaning on that best practices standard. That's the fork of the CIS controls. They're the cherry-picked ones, and they're pretty simple, right? They're very more Boolean, so to speak. They're either on or they're off. There's not a lot of gray area in those controls. So things like, is MFA enabled? Other things like granting least privilege. Well, least privilege is a little bit more gray. So we're going to be looking more for things like, do we have strong passwords configured? That's something that we can set a standard for, number of characters, complexity, all that fun stuff. So that's really what we're kind of looking for, the very Boolean questions. Those are the easiest ones to automate and replicate and put here in our automation. So in order to do this, what I've been using is a couple of different security tools. The first one is this AWS audit collection that we built while I was over at Postman. And the reason why we were using that, besides dog fooding our own tools at the time, is the Postman has a free tier, right? So that means that by us creating and sharing it there, everyone who wants to use it or share it or inherit it can, because it's free to download the tool, install the tool, pull down the collection and use it, right? But we understand also that not everybody wants to use a specific tool. Not everybody wants to have to take this kind of auditing out of their existing pipeline or their existing security stack. So we also export it to different types of languages, and I'll show you kind of how we did that in a minute. But what this is doing is we're looking at 9 specific controls, and we're going to report the results of every non-compliant resource. And the best part is that you can leverage it across different accounts, and that enables you to cover the more complex deployments, right? Not every company is using a single AWS account. Not every company is using consistent standards to audit and remediate and enforce controls across all their accounts. Some of them are not using AWS organizations and things like that to enable those additional controls. So what we wanted to do here was make this flexible, where it is not a dependency to use this tool to audit your accounts to have the AWS best practices employed and configured in your account. This is for people that want to get to that tier of having the best practices enabled, but aren't there yet. That's what we're really trying to help out. All right, so the collection itself, this is that Postman tool, the free one. And what this collection really is just a bunch of web requests. So, who here has used Python or JavaScript or curl, any of those kinds of toolings? Those are all able to use things like requests in order to communicate with web services. Why, do we care about that specifically? And that's because APIs kind of make the world go round when you're talking about cloud. One of the things that we developed for when building tools in AWS was an API first mentality, where if you could do it in the console, you have to be able to do it by the API. So using the AWS CLI tool, or just having your Boda 3 support in there, so you could do like a Python script against it, or Java or whatever. And the idea of that was removing that kind of disassociation between what's capable in the service and what users are able to do, right? When you use a proprietary platform, a lot of things are black box, right? You know how things go in and you know what comes out, but what happens inside is a complete mystery to you. So with REST APIs, what we're doing is we're really just communicating with the service directly. And it's a kind of language agnostic way of doing it. You can interact with this REST API via JavaScript, Python, Java, probably Perl, Anybody use Tickle or any of the other fun languages? I bet that even Bash, you could write your own script and use curl or wget in order to interact with this and have similar results. So that's why we're trying to really focus on that REST API. It's because we're breaking it down to the least complex communication mechanism between the services. And that's going to help simplify things like speed and also the results that you're going to be getting. Now, you can go up to, I think Postman's hosting this still. If not, it's on my GitHub to pull down this collection, and you can just import it, and you end up getting prompted with this, which is called an environment. Now, when you do these REST API commands and interactions, if you're using AWS CLI tools, this would be your AWS credentials file on your system, right? That's where these credentials would go. If you're using Python, you'd be putting these variables into the header, or however you feel like transferring the credentials over. Or in a tool like Postman, you have an environment where you can add these collections. Now, one of the reasons why I liked developing in this is because I could use multiple environments and I could flip between development and production really easily. And I could just write the same code and use the exact same code with different credentials, which was nice because that means I didn't have to constantly abuse our CI pipeline every time I changed between wanting to run this in production versus wanting to run this in development. Now that we have these credentials, there's also another thing highlighted here. So we have the access key and the key ID, that's for the AWS side, right? But we also have a Slack webhook URL, and that's going to be part of our notification system, right? Because we're breaking this down into those two buckets, visibility and accountability. If you can't see it, you can't account for it. So part of the automated process is getting us those results. Instead of having us have to go get them, it's just going to notify us every time it runs, right? That's kind of the tier one way of doing it, right? Just notifying me if something goes wrong. In future talks, I'm going to talk about the rest of the automation workflow where we actually take the results and move it into a remediation system that we created with some lambdas. And basically, based on the results, it will not only notify the security team, but it also notifies the owner of the non-compliant resource, tells them what it is and what they need to change, and gives them a set amount of time. And based on if it warned them once, twice, three times, whatever, within a set amount of time, it will then auto remediate the issue. And say it's a access key that didn't get rotated, it will lock them out, right? So we're able to do a lot of that automation and really help you sleep better at night. Now, I know that I'm running a little bit longer than I wanted to. So basically, I run the collection. And to do that, I just press the, that really pretty run button. And as you can tell from most of my work, it's very complicated and complex. All right. So now we have a successful run. And I ran the first time, and I don't trust first time running. But what we're able to see is that from these results, when we kind of zoom in on them, is that we had a bunch of successful web requests. Now, one of the reasons why I'm using this tool specifically to demonstrate a lot of this is because of the console output. I tried doing this in Python like 3 different times, and either the verbosity was 0 or it was a war and peace every time something outputted. So we're going to stick to this nice, simplistic, pretty output. And what we're seeing here is each get in this kind of list is another web request going out. And then in the green, you can see what the HTTP response code is. And 200s are accepted. So for this, going down through each and every one, we checked list all the account aliases, get the account summaries, checking to see if the root access keys are disabled, all these different things. And in fact, you can see that I have some violations in the account I ran it in. And I know why, because last time I spoke at Security Cloud Summit, my friend Marta and I that wrote the AWS Detonation Lab that we demoed, created this account. And I purposely left it abandoned just to see what kind of outputs I would get on tools like this. And I can see that, Marta obviously hasn't logged in and activated MFA in her account. And then also I have a test user that hasn't been active 180 days. So these are all great things to know that I need to clean up in this environment in order to get myself up to that best practice standard, right? I want to level up. I want to punch above my weight class and really start getting this stuff tightened. Now, as I said, what we're talking about here is more of a tier 1 alert. So we're just notifying them of the issues. Here, simple Slack, webhook just sends it out and says, these are the things that happened. It gives me a nice printout of green if it was compliant, and it gives me a red for when it's not. Very complicated. I had to explain it to management at least 20 times with pretty pictures. Just kidding, Josh. So the next thing up here, if our screen goes, there we go. What are we actually auditing, right? We just talked about all this fun stuff that we're going through and playing with. Now, do you guys actually remember what it was? Well, on slide 6, if you're human like me and can't remember, this is the full list of things that we're looking at. And what's really nice about this list is these are some great standards, right? We want to be able to answer all of these questions about all of the accounts within our environment of ownership, right? Whether or not that's a master organization account with a bunch of members, whether that's the Wild West of every person can open their own account whenever they want, any of those things, as long as we're able to get account IDs or these AKIDs for accessing them, we're able to run these audits against those accounts. And that is what I consider incredibly important with this, because the barrier to entry is lower. More people are going to be able to use these tools to ask these questions. Are they the best tools out there? No. Do they give the best results and best information possible? No. But they can be run and give you some answers, which is better than not being able to run and giving you no answers, right? Yeah, I think, was it the great one said, you miss 100% of the shots you don't take? We're using this to take a shot. Now, as I mentioned before, some of you probably don't want to use, proprietary platform or things like that. So what I did is I leveraged another cool feature where you can create code snippets. So you create all the requests in the console, and then you click on the little code snippet button, and then you choose your language of choice, and it automatically converts it from the web request in that collection to code. So here, you can see curl, PowerShell, Node.js, and Python. Now, I mostly used the Python ones. So I basically went through and grabbed every request I created, converted it to Python, dropped it all in a bunch of different definitions and functions in my Python code, made sure it worked. And then I threw it in a Lambda, and boom, now I have a Lambda running, doing all these audits and actually sending all the information that I need to me. And that's the stage 1, that notification aspect, having it all work. And the next one is, because it's with the Lambda, you can start calling other Lambdas to remediate in the next stages. So now that we kind of see that we can output stuff, is it working? Well, this is a graph kind of dictating the health of my requests. You can use any kind of tool for that. You can even use Burp Suite if you want to check success codes of requests. But basically, we can see, yes, it is working. I had to fire every 5 minutes because I want to fill up a graph. And this kind of shows it's repeatable. It's consistently asking questions, it's consistently getting responses. It is consistently auditing. So now that we've had it run a few times, we've seen that we get a bunch of different reports. So what do we do now that we've been alerted to all these issues? Well, remediate, right? that's what we really need to do next. We need to take care of the issues that we found. And that's where I kind of want to leave things on the defensive side, right? Because we really went through a couple of basics here, right? We wanted to talk about how things really work at the most simplistic level, which is where we start interacting with that REST API of AWS, whether we do it through the AWS CLI, direct web requests with curl or whatever, through Python, through the request module, whatever mechanism you want to do to access, you're still accessing the same thing and interacting with it the same way. So we can choose what tooling we want to create the most efficient and effective pipeline for us to be successful with that. Now, I don't know about you guys, but I, for one, like to test my alerts and audits are working. So let's do some bad things to validate our alerts are kind of working. Now, as mentioned earlier, as one of the co-authors of AWS Detective, it's a incident response tool, right? It's an investigative tool. It's meant to be used to enable people to investigate AWS findings. So in order to test how the tool investigated, I had to reverse engineer some of the findings that were created in order to generate not just the finding event occurring, but also all the associated telemetry, right? If I have an SSH brute force attack, alert finding fire and guard duty, I don't care about just SSH happening. I need to see, there's the 300 requests that occurred from source IP over the correct port within the same bucket of time and all that fun stuff. So I needed to create these things. What you're seeing here is that massive script I created of all the attacks into a collection that I created so I can repeatedly run it. And what happens is you start the collection. One of the attributes you give it in the environment is a vulnerable web server. It's running PHP. It's a pretty common server-side request forgery attack. You can Google it. It's been patched for years and years. So that's why I chose that one. Then once I'm able to get that, I get remote code execution on the server. I'm able to run a couple of local reconnaissance, list users, tell me who's on the box, stuff like that. Then I'm able to exfiltrate the metadata credentials. So that's the metadata service running on my EC2 instance, and use that in order to basically abuse privileges inside my AWS account as assuming that user. Now, I chose to show this because the metadata service v2 completely mitigates this issue. So the two things I'm going to show you are 100% sure patched and 100% sure mitigated if you choose the right settings that you're supposed to be doing by default and best practices. Also, I'm not giving you the direct code because I don't want to get sued. They have way better lawyers than I do. I live in the sticks. So next up, we're going to run our attack collection. And it goes through these 16 stages. Everything's really small because it's just showing everything ran successfully. But what we care about here is we're going to break things down, right? If anybody here Googles credential metadata service, it gives you this URL, right? Because you're basically doing a web request to a local web server that runs this data here. You can see me run it. I'm looking for the current instance profile that's attached, and I grab the security credentials, and I can see what they look like here. I had to edit some stuff out. And then what we can see is in the response body, I have 3 different credentials. I have my access key ID, I have my secret access key, and I have my token. Now, this matters for this kind of attack because the token is more ephemeral. It's timed. It's going to expire, and that's why you see the expiration there. Now, what I'm going to do with this is I'm going to use it to then start making questions against the AWS account. But because I'm currently on the box, I might as well do some local recon as well, view the Etsy password file, I can pull who's logged in right now. It all depends on the privileges of the web server that I just popped in order to do this. So what I'm going to do next, if the slide changes, there we go, is I'm going to start doing some stuff on the AWS account, right? What should I do? Maybe create a little bit of persistence. I can do a lot of stuff, but I only have 25 minutes to talk. So what I'm going to do is I'm going to create a new SSH key on the AWS side, which you can see me here calling that REST API to do so with the privileges of the instance profile that I was able to use. Now remember, the instance profile, I can only use whatever privileges are associated with it. So if you're a developer, don't use an admin one, right? Least privilege, because if you get popped, they're going to be able to use whatever privileges you gave that server. So don't use admin, even if you get frustrated. Like, don't use admin. Now that I've been able to create the attack, that fast forwarded, I'm able to start doing things like creating a new EC2 instance with that SSH key I just created. So now I have an EC2 instance running in that account that only I have SSH access to as the attacker. Now I can install whatever I want, Bitcoin miners or whatever. And I have the ability to do that because I have the SSH key that can get in, right? And you're able to do some other networking things to help stop that, but we're not going to dig into it this moment. What we really want to do is test, did our auditing work, right? So what do we see on the AWS side? Well, what I just did is called the exfiltration of instance credentials. So that is a known attack. That's why metadata v2 came out to prevent it. And this is a guard duty finding that was created specifically for this event, right? So once again, don't want to get sued, showing you things that can be stopped and detected. But why this one really matters is because if you abuse how many privileges you give a profile, you're going to end up running into this issue. And what we care about is, would we have seen this in our audit? Well, yes. Yes, we would have. And how do I know that? Well, number 8, if you guys remember, was identify all the permissive policies attached to roles. So what we can do with that is we're finding overprivileged roles, right? We have that admin role that get attached to it. We have an asterisk there. We can use other tools like PMapper and things like that, Access Analyzer in AWS to help get through this. And you can attach that to your collection as well to do auditing to make sure the right profiles and policies are attached to things. Now, with that, I am done talking, and I want to basically open things up for questions. Thank you for your time today. Remember my motto, flag it, tag it, and bag it. And while there's questions, I will also have my reference links. So the code is available here, the reference to all the tools and technologies, whether it's Slack, AWS, Postman, Twitter, any of those things that were used in this, all of it's here. So you can grab it and use it as well.
Hey, Ryan, great stuff. Awesome presentation. You just showed that guard duty screenshot, and there was a question that came in. Hey, well, what about AWS Trusted Advisor? You showed a lot of great examples here and how to find some stuff. And the question is, hey, wouldn't it be easier to just use AWS Trusted Advisor? And why wouldn't you use it in that particular case?
Well, one of the things that's fun with any cloud service, whether it's AWS, GCP, or Azure, is that every service you use has additional cost. So if you're going to use all the features of one of those services, then it makes sense to use that service, right? Because you're getting that return on investment. In this case, we had a very specific example, specific use case, and it was significantly cheaper to just run a Lambda hourly to do the check and tell me any of the bad stuff that happened. So really, the decision came down to dollar signs, and I'm poor.
It makes perfect sense. That's a good reason. Hey, this is a perfect timing here. You're getting some shout outs in Slack here. So let's go ahead and move the conversation to Slack. Everybody, let's give Ryan a virtual round of applause. Thanks so much, Ryan, and look forward to
Thank
seeing you
you.
at the next one.
Have a great one, guys.